So now that we've had some practice with looking at identities and using them to simplify identities or prove new identities, I want to come back to implication. So in particular, in Rosen, section 1.3.2, in table 7, he lists 9 identities about implication. And indeed, some of these identities we've already seen. So for example, he lists off one of these identities right here. However, Rosen glosses over the concepts of contrapositive, converse, and inverse. And in fact, Rosen only devotes a couple of sentences to contrapositive, converse, and inverse way back in section 1.1. However, these concepts of contrapositive, converse, and inverse are so important that I think it warrants revisiting implication now that we have access to these bunch of identities that we were looking at previously. So first off, what I want to do is define what contrapositive, converse, and inverse are, and then using the identities that we've had practice with, go ahead and see how these conditionals or implication statements right here relate to contrapositive, converse, and inverse. So I'm going to go ahead and write down some definitions. And I'm going to make a note right here, and this note is actually a claim. So this claim is P implies Q is logically equivalent to the contrapositive. So the definition of the contrapositive, so if our original statement is P implies Q right here, then the contrapositive is not Q implies not P right here. Our second definition is going to be converse. So the converse of P implies Q is Q implies P. So all I've done right here is flipped the P and the Q and left the arrow pointing in the same direction. And here I'm going to make a note that Q implies P is not logically equivalent to P implies Q right here. And lastly, we have inverse. So the definition of inverse, P implies Q is not P implies not Q. All that I've done right here is thrown a couple of knots in front of my P's and Q's, not change the order of anything. I'm going to make another note. That the inverse is not logically equivalent to the original statement right here. And so, why would it be important to understand the contrapositive, the converse, and the inverse? Well, later on when we start talking about proof techniques, it's going to turn out that some statements are a whole lot easier to prove if you consider they're contrapositive, or if you consider an argument based off of a converse or an inverse. So sometimes instead of trying to prove a P implies Q right over here, it might make more sense to prove not Q implies not P. And we're going to see examples of that a little bit later on.